Alrighty, Tommy Rio want to give you a little update. I ended up getting some material in. I ended up cutting this little tank. This will be the bottom. I still have to clean it out. I ended up putting it in the fire and just burned all the paint off so I can really clean it up real nice. And this is the rotary. I've been thinking of probably machining this, but this is probably very hard metal, so it'd be a pain in the neck to do a thread. Might have to get a little bit different kind of metal, a little bit easier to cut. Threading could be a pain in the neck, especially on that. So I want to show you where we're at. I finally got my pipes in for my turbine. Now this is the interior turbine. It's a little bit long, so I'm going to have to actually shorten that a little bit. And this is my elbows for my orifice. That's a 3/8. So it goes from 3/4 to 3/8. And then I can drill my 1/16 of an inch jets. And I got 4 of them. And this is the ring. What this would do is basically go in here. Right now I already got all my holes drilled. But the bottom is going to be welded, so the top I can access it and then do the planetary gear and stuff like that I need to. Now I got to make this a little bit more smaller because I'm going to have the Pelton wheel that's inside. It's actually on another shaft, so it's a shaft over a shaft. So the main shaft, which would be the 1-inch shaft, would be in for the main turbine. Then there's a sleeve that comes down with a roller bearings that has the counter rotation disc. It's basically the jets hit the Pelton wheels and cause it to go in reverse direction. So it gives you a pretty good idea of the simplicity behind it. This is nothing new for me. This is pretty easy stuff because I built so many of them, so I know how to put things together and basically know how to do all the little fabricating. I have a nice rotary table. This was a Vevor, I believe it was. Works good. It works good enough where I can do precision drilling, and that's all I really needed. And pretty much I want to show you what other things I ended up getting. Got this on Facebook. Generator. It's a 5200 watt. And believe it or not, the guy said it has a C's engine, which it is pretty much seized. So it's not going to turn over, which is typical on these engines. I've done a lot of repairs down in Florida, worked on all kinds of engines and generators. And a lot of times the oil sensors go bad. So what happens when they get low on oil, they basically lock up the engine. That's probably the case. I'll tear it apart. Does have a starter. All this stuff is, to me, it's money that I'm actually gaining. Starter is worth a lot of money. But the generator is what I was really concerned about, which I want. So what I'm going to end up doing, if the engine is actually locked up, I'll tear the whole thing apart. What I'll end up doing is cutting off the crankshaft tongue, because it's a taper. It goes inside a generator. It's a tapered design. And then I'll machine it and put a bearing in the front. And then that bearing, now I could put a flywheel on it. So this is a 3600 RPM. This isn't a 4-pole. If it was a 4-pole, like some of the old ON generators, they run at 1800 RPMs. So this has to spin pretty fast. That means I have to do the math on getting this up to speed to be able to turn that generator. And what I'll probably go is a 1-to-2 ratio. So if this is spinning at 2000 RPMs, that means the other ratio will be about 1000. But I need roughly about, basically I'm going to need this at 1800. I want this to spin at 3600. So that means, what that actually means I need double the amount of torque to do that, because you don't get no free lunch in this kind of program. So basically that's where I'm actually going with this. So it's a little bit, actually this is so cheap, 20 bucks. I mean, you got to be a caveman not to buy this. I mean, geez, that's cheap. So to me, everything has a price to it. And it was a good deal. So the main thing is building this up, making enough horsepower, and that's where the trick comes. Around 500 PSI, I did some pre-calculations. I can get this up to 2,500 RPMs, but I really need about 1,000 PSI, because that would give me what I'm actually looking for. The max at 1,000 with 4 orifices of a 16th of an inch. It gives me roughly around 28 foot-pounds of torque. Well, actually 28 pounds. The foot-pounds would actually depend on if this was a foot away. So it's about 21, 22 foot-pounds because this is about 18 inches instead of 24 inches in diameter. So basically at 20 foot-pounds, even at 10, if I take it down to 10, which is 20 would be the max. That means it's not doing any work. So I'm not really getting any thrust. I have to cut the RPMs in half. So at 2,500 RPMs, multiply that by 10. That's 10 foot-pounds. And then you're going to divide that by 5252. That's what you're going to determine the amount of horsepower that you're going to get on this. So it gives you it's a real simple math. Just like any generator, you can do that with any generator. The reason this takes double the amount of horsepower, number one, is it's a 4-stroke. So it's only firing 1,800 RPMs. I mean 1,800, but the RPMs on the engine is going 3,600 RPMs. So because it's a 4-stroke. Now, on this particular one, if you ever want to find out how much torque is needed to get the horsepower, you would take the 11 horsepower and you will multiply that by 5252. And what that would give you is a constant. And then you would divide that on the amount of RPMs. So if this is running at 3,600 RPMs, you're going to actually find out what kind of torque it's actually producing. But this is nothing compared to the turbine because the turbine has a constant. It's not a 4-stroke, so it gives you a much more realistic output. So basically, I'll try to put up the math on the comments and show you where it all comes down to. But overall, that's my main objective: is get this up and running, and then get basically get it together and put everything together, and then I'll work on the main combustion chamber, which is the hydraulic combustion system with the accumulator, which is about 3 gallons of or I think it's 11.3 liters of fluid. So that gives me a lot of kinetic energy on there. We're going to use this. This is 16 gallons per minute. More than enough. That's basically what my calculations are telling me. I need at least 16 gallons per minute of flow if I'm going to run this at full power. So that's pretty much the update, and I hope you enjoyed this little update. Tommy Reed, talk to you later.